Hi, this is Josh, and welcome to my SAT math course tonight, JW2542 tutoring on October 31st, 2023, Halloween night, for lesson number 8, quadratic formulas. We're going to give just a minute of grace time to see if anyone else will join the Zoom room, and we'll begin this focused lesson on quadratic formula and the related questions related to it. Just as a quick announcement, my name is Joshua Weiner, and I developed this course, and I'm still developing it over the course of 10 years, working for tutoring houses in Brooklyn, New York. This course is currently being shared as 22 modular lessons that are like a checklist of skills that you should know to perform well on the SAT math section. If you'd like to donate to the development of this course, remember that the recommended donation is $50 per lesson, but I am offering it for free online. You can donate as little or much as you like, if whatever you think the course is worth. And this is a voluntary donations at Venmo at Joshua Weiner 10. If you would like to support my continued work in developing this course for students for the SAT exam. The SAT exam has two math sections in its current form, and we'll focus on mostly 9th and 10th grade mathematics in algebra, geometry, coordinate planes, charts and graphs, probability and statistics, and a few other math topics. Section 3 is currently still no calculator, 25 minutes and 20 questions. And Section 4, the math test, is with a calculator, 55 minutes and 38 questions. If you're getting ready for a standardized test, such as a Regents or the SAT or ACT exam or an AP exam, it's good to have a checklist of skills. So you should work with a tutor or tutoring house to help you get organized so you can perform your best on the standardized test. This class I've been developing for over 10 years, and here's the 28 lesson version, where you can see that mostly the first 10 lessons focus on algebra, and then we focus on topics in geometry, trigonometry, charts and graphs, and probability and statistics. What's good to note is for this exam, the math sections are arranged easy, mid, and challenge level, as you can see from my lessons here for tutoring houses in Brooklyn. Section 3, which is 20 questions, for example, the first 15 questions are multiple choice. So the first block of 5 are clustered easy level, then mid, and then challenge level. And then that little microcosm continues in the grid-ins of 5 questions. Most of the time, the easy questions are first, and then the mid and challenge level questions are at the end of the grid-in section. So a good strategy for anyone taking this test for the math section is to do the first 10 questions in section 3 fast and accurate, skip the challenge level questions, and do any grid-ins that are easy for you. Mark the time, say you have 12 minutes left, then go back to question 11 and finish the section with those remaining minutes and any other questions you skipped. Similarly, in section 4, which has 55 questions, it's good to do the first 20 questions fast and accurate, skip questions 21 to 30, do whatever grid-ins are easy for you, then mark the time, say there's 23 minutes left, then go back to question number 21 and spend the remaining time doing any problems you skipped and doing those problems 21 to 30, which are most difficult for section 4. With this strategy at tutoring houses, I personally have been tutoring for over 15 years for this exam. We found that had over a 90% success rate if you focus on those 37 questions, meaning questions 1 to 10, and then 16 to 18 in the grid-in. And in section 4, 1 to 20, and 31 to 34 in the grid-in. That will give you a score, if you're accurate, of already a base score between 5 and 600. So this can help you get confident for this standardized test to be at the mean score or center bar on the normal curve. So based on the 1 million to 2 million students who take the SAT, the average score is given a rank of 500 points. And then using a statistical concept called the variance and standard deviation, you can see that each standard deviation earns 100 more points to the right, with 3 standard deviations based on the collected data being a perfect score of 800. Also, 3 standard deviations below, it will give it an SAT score of 200, which is the lowest score for showing up and attempting the exam. What colleges are really interested in most standardized tests is to work with a community where you're performing on the right half of the bell curve. Meaning for this exam, you want to score for both ELA and math, a score of above 500 on the English section and as well as on the mathematics section. So by using a good strategy, you too can, doing the easy and mid-level questions first, you too can boost your points and manage your time more wisely for this timed exam so that you can be on the right half of the bell curve. If you're working with this course and you'd like to go from a 500 to a 550 or to a 600 or 650 or 700, or even if you're working on that perfect score, it's very good to use a checklist of lessons like these 22 lessons that I'm offering you here for free. And tonight we're going to focus on section 8, quadratic formulas, which is based on the quadratic formula you see in center here of page 1 of the course of the lesson that I wrote. Before we get to this lesson, we're going to start just like we do in the tutoring house, and we'll have a warm-up quiz. So the quizzes are designed to be have 2 easy, 2 mid-level, and 1 challenge level question from the hundreds of questions we have to get ready for the SAT exam. So what I'll do here is I am Josh. I will share the link here also in the chat window for SAT quiz number 8. You can see the blue link here. If you pause the video, you can cut and paste it. And I'll leave these links active for you on my Columbia University Drive, so that if you'd like to work with this course to prepare for your SAT exam, going through these skills as easy, mid, and challenge level, you can access the quizzes, classworks, and homeworks. So good luck on tonight's SAT quiz number 8. I'm going to mute and give you 10 minutes for these 5 practice questions. So good luck tonight on quiz number 8. If you're watching this recording, you can pause the video, attempt the questions, and then after you submitted your work, you can scroll ahead 10 minutes on the video. Okay, good luck tonight on SAT quiz number 8. Okay, please finish the problem that you're working on. And if you're working with the Google form, please go down to the bottom of the form and click the submit your final answers for in the bubble sheet below for the 4 multiple choice and the 1 grid in problem. That is time for SAT quiz number 8. You then go to the bottom of the form after you've entered your name, email, and written your name. Click on the blue submit button. The school computer should auto grade it for you on a scale of about 1 to 5 points. What we'll do quickly is I'll go over the quiz for you with a method to solve each problem in less than 2 minutes. Here we go with question number 1. Question number 1 reads, if x squared minus y squared equals 24 and x plus y equals 12, then what is x minus y? Well, this is easy level if you know your factor patterns from previous studies. We can take the difference of 2 squares and rewrite it as x plus y times x minus y. That also equals 24. So if you know this factor pattern, we can rewrite it. Then we're given that x plus y is equivalent to 12. So we can put that in for the first factor, times x minus y equals 24. Then simply divide both sides by 12. That'll cancel the 12s. And x minus y is 2, meaning the difference between the two values, unknowns, x and y, must be 2. The correct answer was D. Question number 2, also easy level. We can see here that it says, what is the solution to the double inequality? Negative 10 minus 3w is less than 2w, which is less than or equal to 90 minus 3w. Well, here we have a double inequality, so we can add 3w to the left side, the middle, and the right side, and rewrite the inequality. The left side will simply be negative 10. In the middle section, we'll have 5w. The arrow is not flipping because we're simply just adding and subtracting, so it'll still be less than or equal to, now it's 90. Then divide each space by 5. So we have negative 2 is less than w, but at the same time, w must be less than or equal to 18. And the correct answer was B. Negative 2 is less than w is less than or equal to 18. Question number 3 is a statistics question, and it's written as mid-level. Here we have a set of numbers for data, and we have to figure out the mean, median, and mode based on the given numbers. Well, the first thing I'll do is I'll see, well, how many numbers are in the set by putting up a partition block here, counting by 3s. So it turns out there are 9 data points or 9 elements in the set. So now I'll arrange them from least to greatest, just going through. I see that 1 is the smallest number. And then it looks like 3. There's a couple of 4s. Then there's 3 6s. And then 7 and 9. And just so that I don't get lost, I'll just put those partition bars there so that they're in bins of 3. If it's easier, if you have a highlighter pen, you can do is you can just highlight the blocks just to make sure that you're counting 9 numbers. Just block them off in 3s, right? With like a highlighter, yellow highlighter, or any color. Here I'm using a gray boxes. This immediately tells us the median, which is the middle of the set. And that is 6. So the median is 6. Also, the mode is the most frequent, and the mode is also 6 because there are 1, 2, 3 6s in the set. And there's no other element that's repeated 3 times. So here's the mode. And we have to calculate the mean or average by adding the numbers and dividing by 9, right? So how can we do that fast? Well, what I do is I try and block off in tens, and here it works nice with Rainbow Edition. 9 plus 1 is 10. That's 20. That's 30. That's 46. So the total is 46, and we have 9 elements. So that gives us 5 1/9 is the average for the set, or mean. So let's look at the 3 statements and see if they're true or false above based on our mean, median, and mode. The mean is larger than the median. Here's the mean. 5 1/9 is larger than the median. That is a no. So we'll put a red card over that. That is false. The median is 6. That is true. We'll put a green card over that. I did that in green. That is true. The mode is 6. That is also true. So we have 2 true statements, and we have 1 mathematically false statement. Looking at the answer choices, the only match is choice C. 2 and 3 only are true for question number 3. Correct answer was C. Question 4. What is the x value in the solution to the system of linear equations below? Well, this is a little tricky, but the shortcut here is to look at that as equation 1 and equation number 2. So we'll do that way. So what I'm going to do is I'm going to leave equation number 2 the same. I'll write it down here as 3x minus 4y equals 16. But to set up for this, I'm going to take the first equation and multiply the entire lot by 4. Then we'll have 4y equals negative 3x plus 6.5. Next, what I'll do is I'll rearrange the terms of the first equation so that 3x is on the left side. It's in standard form. Then we'll have 3x plus 4y equals, actually it's 26. Why did I write 6.5? Hold on, please. So I forgot to multiply the 6.5 times 4. I did that earlier when I was working on it. Negative 3x plus 26. Right. Okay, so that's the same equation, but now it's in standard form. I'm going to move over equation number 2, which is already written for us in standard form. And then, just like we mentioned in previous lessons, if you've been following my course, we can do the SAT shortcut where you add or subtract the 2 equations, and it'll cancel a variable. Here you can see this column here will cancel if we add the 2 equations together. Lo and behold, by addition, we'll have we add the 2 equations together, we shall have 6x plus 0y is 42. And then simply dividing both sides by 6, x equals 7. So the correct answer was A, 7, for question number 4. Last one, there are 2 30, 60, 90 right triangles drawn. Okay. And the hypotenuse of the smaller triangle ABC, AB is 8. Let me try and label this here. This is A. This must be B. This is a smaller triangle. That's the hypotenuse. So this corner should be 90 degrees. This corner is 90. Okay. Then it says the hypotenuse of the larger triangle DBE is 12. You can see the long side. This must be the right angle. Now it's like so. And B, it says DB, so D must be this corner here because B is in the center. So this is D. A to B to D and C to B to E are straight line segments. Let's see. D, A, B, C is a triangle. So this must be corner C. That's the third corner. D to B to E. So this must be vertex E. Okay. So now we're trying to find the right angles are C and E and the short sides are AC and DE. Aha. So since those are the short sides, we can say that the short side is opposite the smaller angle. And it looks like it's drawn that way. These must be the 30-degree angles here. Maybe it is easier to read in light blue. So should I erase the... Yeah, let me erase the 90s and then put them in light blue. Okay. Or maybe white's even better. Or yellow, so it stands out on the page. This angle's 90. Yeah, this angle's 90. Those are 30s, so these angles must be 60. So now I have the orientation of each triangle. Right? It's sort of like twisted. They're similar, but there's the vertical angles are here, like a bow tie, like a twist in a bow tie. Right? This triangle has a 90-degree angle here at the base at C, but now it's inverted here on the other triangle. Okay. The other thing that we're told is that A to B is 8, right? And B to D is 12. But we know from our reference triangles that the hypotenuse is half the height of the triangle, is double the height of the triangle, excuse me. So if the short side is 4, if the hypotenuse is 8, the short side is 4. If the hypotenuse is 12, the short side is half. What's half of 12? 6. Yeah, it's half of the hypotenuse. But if you remember your reference triangles, this is going to be 4 root 3. And this one will be 6 root 3. And I have to draw in the squared symbols because, unfortunately, they don't do that for us. I mean, I really have a font too. There. Maybe I should have preset this. 6 root 3 is BE. C to B is 4 root 3 because these are 30, 60, 90 constructions, reference triangles. So then the writer says, well, we want to know the entire length of CB to E, this green line. CB is how many root 3s? Well, it's 4 here and 6 more, which I'll highlight with bubbles instead in just a second. So that is 4 root 3 plus 6 root 3 is the total length of CBE. So 4 plus 6 is 10. Correct answer is 10 square root 3s. If you put 10, you had the right answer for question number 5. A equals 10. All right, so there's my review of the 5 quiz questions. And now let's get to the core lesson. This week, we're focusing on the quadratic formula. Before I do that, I have to... There we go. Here we go. Okay. So quadratic formulas. In the previous lesson, we worked on a variety of SAT skills to factor quadratics, many of which start in standard form, f of x equals ax squared plus bx plus c. Some students find it more useful to solve for the zeros or roots of a parabola by using the quadratic formula. So this lesson will cover topics with the quadratic formula, using solving for zeros, the axis of symmetry, and the nature of the roots. It will also discuss the important alternate forms from classical mathematics called vertex form, which locates the turning point of the parabola as graphed in the Cartesian coordinate plane. Here's example 1 using the quadratic formula, ax squared plus bx plus c. What are the zero solutions to, here's the first example, f of x equals x squared plus 3x minus 10. Well, what we're doing is we have the equation already in standard form, and we need to extract from it the coefficients of the terms here. There's only one square, so a is 1. The middle term is 3x, so the coefficient is 3, b is 3. And here we have the constant is negative 10, so c is negative 10. Then we can plug in a, b, and c into the quadratic formula. What I'll do is I'll take the liberty of using primary colors. So a is 1, right? So wherever we see the letter a in the formula, that is where 1 is. So we have b squared minus 4ac, so we plug in 1 there. And b is 3. So wherever we see a b, we're going to put the number 3. So negative b plus or minus b squared minus 4ac over 2a. And finally, c, which I'll highlight in green, is negative 10. So we need negative 10 here in the discriminant for the 4ac part. Okay, so notice everything's consistent. Just make sure that you plug in correctly, and we'll get negative 3 plus or minus 9 minus 40. So 9 plus 40 over 2. The square root of well, 9 plus 40 is 49. So we get negative 3 plus or minus the square root of 49 over 2, which simplifies to negative 3 plus or minus 7 upon 2. Let's see, negative 3 minus 7 is negative 10 over 2 is negative 5 is the first zero. Negative 3 plus 7 is 4. 4 divided by 2 is 2 is the second zero. So we have the negative solution, negative 5, as well as negative 3 plus 7 divided by 2 will give us the positive solution. And we're done. The equation f of x equals x squared plus 3x minus 10 has two zero values, one at negative 5 and the other at 2. It's important to realize that the terms of the quadratic formula can tell us a lot about the function even before we graph it on the xy plane. There are 3 detailed questions about parabolas that are commonly tested on the SAT. Firstly, parabolas are symmetric and they have a symmetry line. Secondly, they have 0, 1, 2, or 2 roots along the x-axis, depending on their location on the plane. And thirdly, they have a turning point or a vertex. So let's look a little bit deeper into this formula here, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And here we're going to focus on one piece of the formula, the part called the discriminant under the square root. Okay, and here I left the square root symbol on, but really what we're doing is we're looking at what's in place. B squared minus 4ac. And something amazing happens here. If b squared minus 4ac is positive, if it's bigger than 0, greater than 0, then there are 2 real rational roots. Be careful, because if the discriminant is exactly equal to 0, if this term underneath here, this expression exactly equals 0, then it's a doubled root. It has one real double root, negative b over 2a. And lastly, if the discriminant is negative, be extremely careful, because that means that they'll have an imaginary square root, right? Because it'll be the square root of a negative number is imaginary. So it will have 2 imaginary conjugate pair roots. Let's look at an example so that you can use the discriminant test to see if it's positive and the roots are real, if it's equal to 0 if there's only one root, or if it's negative, so we have imaginary roots. Here we go. So in these three examples, you can see here that just by calculating the discriminant, it will be verified in the graph as we look at it here. So this graph, which you can see, has two real roots because the discriminant is positive. And you can see this for yourself because, the radical down here is positive. The square root, b squared minus 4ac is 9 plus 40 is 49. I'm sorry, 9 plus 16, which is 25, right? So we get a center line, and we get the discriminant over 2 will be the distance from the axis. So we get one root at -1, and one root spaces out to be at 4. Here, look at the discriminant. It's actually equal to 0 because we have for x squared minus 6x plus 9, 36 minus 36, which is the discriminant of 0. When that happens, you only have one root. You can see here is at x equals 3. And finally, here the discriminant is negative. If we look at the graph, there's no relationship to the ground line. All of the points, the whole locus of points of the parabola, is hanging above in quadrants 1 and 2. And that's what happens when the discriminant is negative. Either the parabola is above, completely above the x-axis, or it's completely below. And here, if you actually calculate the discriminant, you see the zeros are at -3 plus or minus 2i, I being the square root of -1. So that's what's useful here. Just by inspection of the discriminant, this value here, if it's positive, gives us 2 roots. If it's equal to 0, then we get one doubled root. Or if it's negative, you can see that, just be careful, I'll use a different color. You can see that there's no relationship to the x-axis, right? All of the points are either above or below, right? So there are no real roots. So we'll see nothing visually on the Cartesian, the xy coordinate plane. And you can see all the locus of points, the entire parabola is hanging above. There's no intersection with the x-axis. The other thing that's useful to note is that here, first, what we did in the last page was we focused on the discriminant, which is the value of the square root, b squared minus 4ac over 2a. The other thing we can do is we can look at the other ratio here present, which gives us the center line or axis line. Negative b over 2a is the exact location of the axis of symmetry. You should be familiar with this axis of symmetry formula when you're working with this formula. So in other words, the ratio negative b over 2a gives us the center line or of the parabola called the axis of symmetry. This ratio informs us of the correct location of the axis on the xy plane, where it points or crosses the x-axis. So let's look at a few examples, and I'll actually, since I'm using green to highlight it, negative b over 2a, let's see what that looks like on the coordinate plane. So in this example, what I'll do is, to help you focus on this idea, I'll simply highlight it here as the center line. It's negative b over 2a, so it's -3 or 3 upon 2. So you can see that that's the green line. That's x equals 1.5. For this formula, y equals x squared minus 6x plus 9. We have -6 over 2, which gives us, well, that's 6 divided by 2, which is 3. So the center line, the green the ratio, shows that the center line will be at x equals 3, which I'm highlighting here in green. For the third equation as well, x squared plus 6x plus 13, even though there are no intersections, there are no roots, it's all hanging up there in quadrants 1 and 2. You can see that using the ratio negative b over 2a, we now get negative 6 upon 2, which is equal to negative 3. So the center line of the parabola, right, you can see the left branch is the same as the right branch for this locus of points. But the center of it, and finding the location of the vertex, will be at x equals negative 3. The other types of questions with quadratics that are common on the SAT is that they're not in standard form. The square has been completed and they're presented to you in vertex form. Here, the general formula is y equals a times x minus h squared plus k. Well, in classical mathematics on conics, the parabola is defined as the locus of points equidistant from a point of focus and a line called the directrix. In science, we have like glass lenses, like eyeglasses or contact lenses, or lenses in the lab for experiments to focus light. We also see them in car headlights, in train and plane lights. Radio signals and satellite signals are collected from the atmosphere and focused by parabolic receiver dishes. An equivalent form, y equals ax squared plus bx plus c, the vertex form is useful in that the vertex point hk is a part of the equation itself. The distance from the vertex to both the focus and the directrix are the same measure and are denoted as the distance p. Let's look at an example. What are the vertex form of the parabola a half x squared minus 5x plus 14.5x? Well, here your teacher should have taught you the method called completing the square. And here we set the first two terms aside as written, a half x squared plus 6x, minus 5x. Here are the first two terms. And then we're going to leave a space for it to the number of units to complete the square and leave the 14.5 in place. First, we have to factor out the half. And then we have x squared minus 10x. But we need a certain number of extra units to complete the perfect square. To find that amount, you take the b value, divide it by 2, and then square it. So here b is negative 10. So we do 10 upon 2 is 5, and then we square it. So we need 25 units to complete the square. So here it is. We're going to add in a 25 into this trinomial. And now it's the perfect square x minus 5. There it is with the square here. So these three terms get factored into x minus 5 squared. But since we added 25 units to complete the square, we have to redistribute the half. So we have to subtract at the same time a half of 25 or 12.5. So that will keep balance because you can't just add 25 units out of nowhere. Here actually we're adding half that. So the completed square will be y equals 0.5 or half x minus 5 squared, and then combining these two terms plus 2. This tells us immediately where the vertex is. Now we're in vertex form. So you should be familiar with this from your studies. This should be reviewed. But we have that x is at 5. There's our h and there's our k. So we know that at the point 5, 2 is the turnaround point or vertex of the parabola. The other thing to note is that this value a helps us find the focal distance. A equals 1 over 4p. So we can then say a half equals 1 over 4p, and then multiplying both sides by 4p, we get 2p equals 1, or p equals a half, or 0.5. So amazingly, the focal distance, which is the distance from the vertex to the directrix line and the distance from the vertex to the focal point, is exactly a half unit along the axis of symmetry. Here's the picture with all 3 points drawn. The vertex, now that we found the focal distance P, you can see that it creates there's our vertex point. This line is called the directrix line. And the focal point or collection for this parabola happens here. But the spacing between them is exactly 1/2 unit. Let's focus on those 3 points here, these three points in a row. You can see here that there's the focus, there's the vertex, and that's the directrix line, which is this horizontal line. Since P equals a half point, you know that the vertex was at 5,2. So the focus is a half unit above at 5,2.5. And the directrix line is y equals 1.5. It's a half unit below. The last thing on the SAT to note is that if you switch variables, you can actually draw or create graphs of parabolas that go to the left or the right of the coordinate plane. So then you can orient parabolas in the 4 directions of space on the graphing paper. So just be familiar with this, and I'll leave this slide up on the screen. You can pause the video. If we switch x and y, that upward parabola becomes the green parabola on the right. And if we change the sign from positive to negative, we can make a downward parabola and also a parabola with a vertex that opens to the left, such as this parabola here. Well, it's time now for you guys to give it a try with the SAT classwork. We always spend 20 minutes of independent practice. And although I created these worksheets with uniformly with 25 practice questions, we only do half of the questions. So since it's an even lesson when we're practicing, because we have only a 90-minute class, we have 20 minutes to do the even problems only. So please begin SAT classwork number 8. Again, the Google form is being free shared this year online, along with the 22 lessons. And if you'd like access to the entire course, just send me a friendly email at JW2542@gmail.com. And I will certainly provide for you the quizzes and classworks and homeworks, and as well as the support materials for papers and videos for the quizzes, classworks, and homework. Okay, I'm setting my timer for 20 minutes. Please begin. And good luck. I'll see you guys in 20 minutes. Hey, ladies and gentlemen, please finish the problems that you're working on and make sure you bubble in your answers for classwork number 8. That was a 20-minute practice. What we'll do is we'll end this class by going over the results. Remember, you only had to do the even questions only, which works out to be 12 practice questions. 1 to 10 are easy level, 11 to 15 mid-level, 16 to 20 are the challenge level blocks, and then the grid-ins are the last 10. Let me read the answers to you for classwork number 8, which you can save here again if you if you're working with this form. For classwork number 8, a focus on quadratic formulas. 1 was A, 2 was B, 3 was D, 4 was B, 5 was C. Wait a minute, that is incorrect. That is incorrect. I need to refresh the page. Forgive me, excuse me just a second. Sorry, let me reset the slideshow because I had to double check the answers while I was working on that. Exactly. So, pardon me. For classwork number 8, 1 was B like Bravo, 2 was D, 3 was B, 4 was C, 5 was C, 6 was C, 7 was B, 8 was D, 9 was A, and 10 was A. 11 was A, 12 was D, 13 was B, 14 was B, 15 was C. 16 was B, 14 was D. 16 was B, 17 was D, 18 was D, 19 was A, 20 was D, 21 was 25.4 miles per hour. 22 was -4/3. 23 was 89, 24 was 3, and 25 was also 3. Also, why is this color changed here? Oh, what's up with that? Let's get rid of this one. Okay. Let's go back to the slideshow. So what I'll do is it was even problems only. I'm gonna go over 1 easy level, 1 mid-level, and 1 challenge level question. All right, let's look at this one. All right, question number 4 reads, when does the function cross the line 3t squared minus 42t plus 147? So here the math is a little bit different than what you might expect. If I were to quickly sketch the parabola, that would be, say, the parabola. And then we're saying that, well, it crosses twice at the line. It's an intersect as the parabola descends and as it goes back up. Okay, it's in a cross line twice. All right, so let's look at mathematically how we solve it, though. And we'll say 12 has to equal, because this is the line f of t equals 12. Right, that's the red line. So that's f of t. 12 equals 3t squared minus 42t plus 147 is how to solve it mathematically. So we'll set it equal to 0. 0 equals 3t squared minus 42t plus 135. Dividing by 3, 0 equals t squared minus 14t plus 45. And finally, factoring it, we get 0 equals, well, we need 2 numbers that multiply to 45 but add up to -14. It looks like 5 and t minus 9 are the factors. So remember, for the 0 products, if we plug in a 5, this will be a 0. Or if we plug in a 9 for t, this factor will be 0. So those are the 2 moments where the function meets the line. In other words, if I were to put a star point here, this is x equals t equals 5, and this is t equals 9. Those are the 2 moments, 5 and 9. The correct answer was C. 5 and 9 for question number 4. Okay, so this is the fastest way. All right, since f of t equals the function, however, whoops, where's the highlighter? F of t equals this function. There it is on the right. But second statement, f of t wants to equal 12. Well, 12 is this line, this flat line. So we put that on the left. We set them equal to each other. F of t equals that. F of t equals this. So set them equal to and solve. That's how to do it. All right, that was question number 4. Question number, excuse me. Let's go to mid-level question. Easy level, easy, easy, easy. So it has to be either 12 or 14. 14. What is the axis of symmetry? It's actually easy. Because it's in vertex form, we have our HK equals, well, just move this to this side. And we have plus 5 instead. What's wrong with this pen? Plus 5 instead. So I just add 5 to both sides. Then H equals 3 and K equals 5 is the vertex. Because we have vertex form. Right? So then there's our H and there's our K, 3, 5. But remember what the vertex is. The vertex lies on the axis of symmetry. So 3, 5 means that x equals 3 is the x coordinate. That's the center line, which I was drawing in green in our example. Sorry, I'm drawing this freehand. Here. So the vertex is this special point that's on the parabola. We can see here, this star point, that's our HK, right? -3 means, remember, to the opposite sign. X is 3 and Y is 5. H is 3 and K is 5. So that means that B is correct. The axis of symmetry is at X equals 3. Hey, challenge level? What's going on here? Number 20 was challenge level. All right, this one was a little weird. I wrote this one because I was thinking, I wrote the lesson and I wrote that you could do parabolas that go up, down, left, or right, right? So I thought, well, how do you actually code in conics a parabola that is rotated? And so here I did a little research, and I was like, well, this is the simplest I could do it. I could do it as a plugin. So let's read this one where you have a tilted parabola that is in conic form. The parabola I wrote is symmetric on the line y equals x plus 1. It has a focus at 4, 5, vertex at 7 halves, 9 halves, and a director's line y equals negative x plus 7. Boy, what a way of tripping out the SAT students, scaring them the super hard problem. All right, hold on. Let me draw the line. Where is that drawing tool? That's this blue line. That's the directrix. That's the directrix line. That's the blue line. All right. The parabola is symmetric to the line y equals x plus 1. I'm going to highlight in red. That's the line of axis of symmetry. So that means it's tilted at exactly 45 degrees because that's the slope of that line. Slope is 1. So this is y equals x plus 1. That's what it's there's the vertex at 7 halves, 9 halves. Bam, that's it. But then that's the directrix, so the focus must be equidistant. It must be like that. Remember they line up 3 in a row, like the stars on Orion's belt, so to speak. Right? They line up 1, 2, 3 when we're studying parabolas and conics. However, ladies and gentlemen, which point is not on the parabola? Is it 3, 6? Let's mark it off. I would just use, bam, that looks like it's on the locus of points. 5, 12, 5, that's 10, 5, 12. That looks like it's on the parabola. 11, 6, just use the grid. 11, 6, that might be off. Oh, no, because that's 10. Duh. Let me undo that. 11, 6. Now it looks like it's right on the crosshairs. But question mark at 10, 18. Here's 10, 5, 10, 15, 16, 17, 18. Looks like it's inside the parabola here. So I'm going to put an orange rectangle up so you can see that I'm counting the boxes correctly. I'm showing you this. So one way of spacing it out is you go up to the 10 here. We have to raise that up to 18. So I'll put that along the edge of the box here. This is from 0. This is 10 units along the base of this rectangle. And how tall is it? It's 18 units tall. So that gives us the corner point, 10, 18. So that's the suspect point. It just doesn't look right. Doesn't look like that is sitting on the parabola, that one. So now we'll prove it mathematically by plug-in. Here we go. I'll put up a blackboard on the right. And then plugging in for X and Y. Here comes the calculation proving that it is not a point. Okay, X is 10 and Y is 18, right? So we have 100 plus 324. That's because I know my perfect squares. Minus 2 times 180, 360. Minus 20. Minus, what the heck is 6 times 18? Plus 33. Yeah, it's 108. All right. Here's the thing. If I put the positives together, we get 424, 57. And then if I put the negatives together, we're subtracting 380, 480, 4. Saying that right? All right. 3. Let me make sure this is right. Yeah, it's totally right. 360, 468, 488. And that's not equal to 0. So therefore, it's not on the problem, according to the conic formula. So the tilt comes from these unusual terms here. If you like mathematics and you want to pursue higher education math, you'll learn that, yeah, some of these conics equations that you can tilt a parabola by setting up the ratio, the right coefficients. But it's easier to see and do mathematically if you learn matrix algebra or polar coordinates, right? Where you choose an angle theta. And you will learn more of that. Love to go back to that sometime or post a video. If I returned back to my college years of math, where I did years and years of calculus. And remember, there's the grid plane, but there's also planes, the polar coordinate plane, and there's hyperbolic geometry, spherical coordinates. Could go on and on. And if you're going to be an engineer, you have to be familiar with each of these systems of ordering space. It's modern times, if you work with the 3D printer, right? You're thinking in 3D. So this is a blast from the past. The conics formula from Greek mathematics. Conics terms. Okay, let's erase these here. Okay, what are we doing? You're gonna end this 22? No, 24. Blah. What a mess. 24 is a factor review. Why is that mid-level? That should be challenge level. Let's do 22 because it was from the previous lesson. Hopefully you'll come back. Those of you who have been here for the previous lessons live. We're going to factor using front and back pair. Okay. Then we get x squared. And then 3x plus 4. So before I even look at the back pair that we're going to factor, we wanted to also have a 3x plus 4. Well, looking at what's written up there, we need to factor at -1 then. That'll do it. Then we create the new factor, x squared minus 1 times 3x plus 4. This is the conjugate pair, right? So x plus 1, x minus 1 times 3x plus 4. Well, if we plug in -1 or +1, we have two solutions there. But how do you get the solution that's like a ratio? Well, rhetorical question. you set the 0 factor equal to 0. When is that? When that is 0. So that's when 3x equals -4, or when x equals -4 upon 3. Okay, so the correct answer to number 22 was -4 upon 3, -4. There's the math. That's what I do. All right, for you guys. So again, thank you for spending time watching this video and doing some math with me as you get ready for the SAT. This is a comprehensive review of factor skills and useful formulas to you for the quadratics questions. I guarantee there'll be at least 10 of the 58 questions. Its current form, and even when they change it to 44 questions upcoming soon, which is the tentative, they're going to still have at least 10 or even more quadratics questions. So thank you for joining me tonight on this YouTube channel. I forgot to stream it live on Twitch. What am I doing? I'll do that next time. Do that another time. Darn it, I forgot to stream it live. Maybe I can just film it on Twitch. Yeah, film it for Twitch. I can do that. I'll just, it's going to be awkward, but I'll film this recording. You're going to see the recording of the YouTube recording filmed on Twitch as a live stream. Weird, huh? All right. So thank you for joining me here tonight on for SAT class number 8. I'm Josh, and if you'd like to know more about me, you can check me out on my Wix site, which is here. My dad said to, try GoDaddy then if Wix isn't working. Try the other sites, and but it takes a lot of hours to do this, So there I am. You can see praise from parents over 15 years of tutoring. I have prepared students for the SHSAT, the test for Catholic schools, the cooperative exam, high school placement test, the PSAT, New York State Regents, SAT, ACT, AP exams in math, statistics, and physics, as well as the graduate record exam. My students have been accepted into specialized high schools here in New York City, gifted and talented, yes, as well as Catholic school scholarships, the quarter, half, and full scholarships for their families. They're accepted into the college programs of their choice, graduate schools, nursing schools, business schools, medical schools, and law schools. And it's been an honor to be your tutor no matter what grade level you're at, grades 5 to 12, or if you're a college or graduate student. I'm a math specialist. If you'd like to hire me, please contact me through Wix. You can just email me or call me at the number there. My email is still JSMW2542@gmail.com. And I thank you for your kind attention here and for studying math with me. That is it for tonight. If you would like to donate to this course, please go to Venmo and donate to Josh Wiener 10. This is a course in development, which in the end, when it's completely original material, every single question, which I have to go over, then I will approach publishers to have another SAT book on the shelves that serves the high school community. Next class is November 7th at 7 o'clock. Here are the links to Quiz 8, Classwork 8, and Homework 8, which I will leave as open share, free lessons for you. Pay what you like, donation, whatever you think the course is worth. And I thank you so much for studying with me. That is all for tonight. Remember, happy studying and good luck on your standardized exams. Thank you, and take care. Good night. Bye-bye.